Hello and welcome to this hopefully short and easy to understand video explanation of a couple of the math questions that you sent me earlier today. This first one, question 15, I sent you that short video about clearing fractions. I did not learn about this trick until I was in college, and I was just cursing the fate that I had not learned this trick sooner because it's great. The clearing fractions relies on this idea that if we add fractions that have common denominators, then the denominators don't really matter all that much. We actually can just ignore them and add the numerators, assuming the denominators are the same. In this problem, problem 15 that you sent me here, the denominators are not the same. So if we can make a common denominator across the fraction, then just like that example I just showed you there, we can ignore the denominators and just operate with the numerators. So let's do that, starting with 1/2 x plus a fourth y equals -3. So the common denominator here would be 4. We could double number of pieces in halves to make fourths. We'll get to that in a moment. We also have -2/3 x in this system of equations plus 1/2 y equals 9. Not as easy of a common denominator to make because you can't just double one of them to make the other. If we multiply them with each other though, we can make sixths. So here's how this will work. We multiply everything in the top equation by, well, will that work? Maybe just do it like that. Multiply everything, since the common denominator is 4, multiply it by 4. Everything in the common denominator, multiply it by 4. Multiply the other side by 4 as well. The common denominator here would be 6, so we'll multiply everything in both sides of the equation by 6. And here's how this will play out. Can I zoom out a little bit? Probably not in the way I want to, but that's fine. So doing that, with our first equation, if we multiply 4 times 1/2, we just get 4 halves. X plus 4 times 1/4, you probably see where that's going. 4 fourths y equals, and we still have to multiply on the other side as well, -3 times 4 is just -12. And then, like I said, I keep pausing. I'm like, is this even correct? And then same thing over here. We got 6 times -2/3. 6 times -2 is -12, so -12/3 x plus 6. We got to distribute. 6 times 1/2 would be 6 halves y equals, on the right side, we get 9 times 6, which is 54. So those equations, the fractions in both of these will simplify to whole numbers, assuming we did this correctly. So 4 halves simplifies to 2x in the first equation. So 2x plus 4/4 is 1y, or just y, equals -12. That part doesn't change. And in the second equation, -12/3 simplifies to just -4x, plus 6/2 simplifies to 3y. Still equals 54. So, wonderful little trick where now we don't have to worry about fractions as much. Can it be solved without doing that? Yes, but I don't like thinking harder than I have to, so I don't want to think about fractions. So, that is why whenever I have fractions in an equation, I like to, switch sides real quick. I like to clear the fractions first by multiplying both sides of the equation, again, by a common denominator, simplifying every coefficient to a whole number. So now we have our two choices of substitution and elimination, and we could use either of them here. It just it's your choice. For whatever reason, I've always liked elimination, but we'll get there. So if we wanted to use let's think, if we wanted to use substitution, we set either of these equations equal to either x or y. It'd be pretty easy to do it the first one. We have 2x plus 1y, or just y, equals -12. And it lends pretty well to substitution, because if we subtract 2x from both sides, we end up with y equals all of that, negative 2x minus 12, which we could then plug into the second equation. Maybe the reason I don't like using substitution whenever I can get away with it is it ends up with an equation that once we substitute looks like this. So the second equation, negative 4x plus 3, and instead of y we'll substitute negative 2x minus 12, and now equals 54. And that's just gross and unpleasant to me. I don't know why. It's just, for me, too busy, too much going on. You can do it like that though. You can do it like that. And if you want to, you're welcome to, but I'm not going to do it. Simple as that. If you like that better, sorry to disappoint you, you're on your own. I like elimination. Here's how to eliminate. Can we get either of these terms, either the x's or the y's, to somehow or other cancel out? We can do that pretty easily here. If we double everything in the top equation, then we would have on top, double 2x, we get 4x, plus double 1y, we get 2y, equals double negative 12, we get negative 24. The reason we would do that is we have the bottom equation, negative 4x, which is the opposite of 4x, plus 3y equals 54. Because this is a system of equations, we are guaranteed that the x's have the same value, meaning we can combine, we can add and subtract. They are like terms. So the 4x and negative 4x would cancel, or minus 4x, however you want to call it, cancel out, leaving just 2y and 3y, which makes 5y, equals 54 minus 24 is 30. Divide both sides by 5, pretty elementary from there. So we've got our value for y. And now you could take this value of 6 for y and plug it back into either of those equations, substitute it back in. But I'm pretty sure you can do that if you just put 6 into that one. Being pretty generous with throwing you that one, but I feel like I would almost insult your intelligence by telling you what to do from there. Substitute y, or 6 for y rather, and then solve for x, no problem. So the key two skills I think in this problem are, the first one, clearing fractions by finding the least common denominator. It doesn't have to be the least, but it makes for simpler math to do mentally. So multiply both sides of an equation by a least common denominator in that equation to make the coefficients simplify to whole numbers. And then from there, we use either substitution or elimination. It is your choice from there. But like I said, I have a pretty strong preference for elimination whenever I can make it happen. So if you have questions about either method, substitution or elimination, you want to know more about it, if that's the skill that we're like, geez, what just happened with all of this, with, where'd I put it? Oh yeah, over there with doubling everything and making the x's cancel out. What's this guy talking about? That is perfectly fine. Let me know. I'll be happy to explain more about substitution elimination. Even the substitution step, which I was like, or substitution method, which I was like, I don't really like it. I'll still tell you about it if you want to know more. It's perfectly fine. That is the first problem. So I'm going to go ahead and end the video there, so I can make a smaller file size, and we'll do the second problem.